Hello everyone. So today we will be solving the daily problem. So the name of the problem is the total cost to hire K workers. So yeah, I will be solving the problem live, and will discuss my approach and how I will solve that problem. And if I stuck, you can see me where I stuck and how I resolve that issue, and how I will figure out which data structure should I have to use in this problem. Yeah. So first. We have to read the problem statement. You are given a 0 percentage array cost, and the cost of y is the cost of hiring the ith worker. You are also given 200 k and candidates. You want to hire exactly k workers according to the following rules. You will run k session and hire exactly one worker in each session. Okay. So we have k sessions, and हर एक session में we have to get we have to hire one person. Okay. Choose the worker with the lowest cost from either the first candidate's worker or the last candidate worker. Break the tie by the smallest index. In each hiring session, choose the worker with the lowest cost either from the first candidate's workers or the last candidate's first and last. Okay, so left and right. Okay, the for example, if cost is and the candidates are two. Okay, so we have to choose two and candidates from the left and two candidates from the right. Yeah. Hmm. Sorry. Hmm. Hmm. Okay. So we have to choose the minimum from the left and minimum from the right as well. So what we can do is we can take two minips. Yeah. So it should be solved by priority queue. And why I am saying priority queue, because we have to choose the minimum element. So we will be using a min heap. So yeah. So yeah, let's see this example. So we have given candidates equals to 4. So in the first we have these 4 from the left hand side, and we have these 4 from the right hand side. So what we are picking up, we will be picking this element, and then we will be picking the this one, and then what we having is we will be having 2 plus 2 plus the minimum element from which is 2 plus 2 4 and plus 7 11. So yeah. Okay, so let's code it up. I will try to explain you the approach. First we will be trying to solve it. Okay, let's see. Heap 1, heap 2. What's the constraint? The k and candidate should be lesser than cost dot length, obviously. For the dash in range of k. Okay, we have to take I equals to 0, j equals to n minus 1, and while I is lesser than k, we can pick heap push heap of min heap. So okay, we have cost of I. Yeah, and I plus equals to 1. Okay, while j is greater than or equals to I, and we can rewrite it. And count is greater than 0, and heap push heap 2, it should be heap 1, cost of I, cost of j minus equals to 1, and count plus equals to 1. Yeah, for dash in range of k. So answer okay, it looks nice. Yeah, let's try it out. Count okay, so if not heap 1, then we have to just take the element from the second heap. Yeah, heap pop heap 2. Okay, so we have the heap 1 as empty, so we have to take the element from the second heap. Yeah, and vice versa as well. Okay, if we are taking an element from the heap 2, elif not heap 2, oh, it might be a case like we have 1 and we want 3 employees, so we have taken 1, so we will be picking the next element in the heap, so it won't be the case. Yeah, so we have heap and we have heap 2 as well. Okay, if heap 1 of 0th element is lesser than or equals to heap 2 of 0th element, then what we are doing is we will be heap pop heap 1. Yeah, so if I am considering the this example, so in this we have taken 2, so we have to push the 7 here, 7 in the left heap, heap 1. So the condition will be if I lesser than equals to j, so we will be doing heap push heap 1, and cost of I, and I would be plus equals to 1, and that if we have else case, then we have to do heap pop heap 2, and answer if I lesser than or equals to j, then heap push heap 2 cost of j minus equals to 1. Might be it might fail, so we will have to debug that, but first we have to try it out. Yeah, j is n minus 1. Okay, count is candidates, count is 0. Let's do it out. Since candidate and count minus equals to 1, and let's do count is greater than 0. It should work fine as well. It is working, Raya. Great, great. It is working in the first. Let me see the hints. Okay, maintain 2 mini heaps, one for the left and one for the right. Yeah, we are on the right track. Compare the top element from the 2 heap and remove the appropriate one. Yeah, and add a new element to the heap and maintain its size as k. We are not doing maintaining the size as k, we are maintaining the size as candidates. Am I missing something? Okay. Let's try it out. We will figure out if I got any. Okay, I have submitted it previously, but it is somewhat okay. It worked. It is almost a year. Like I have saved it 11th of June in 2022, but now it is 2023. So yeah, it is working fine. So yeah, I will explain the approach to you if there are any doubt. So first we are taking uh, we are initializing first heap and the second heap. Then we are taking the length of the cost array. Then uh, I am initializing two variables, I equals to 0, which is pointing the first element of the cost, and the j equals to n minus 1, it is pointing to the last element of the cost. So and then I am doing count equals to candidates. So like here in the first example we have given candidates equals to 4. So why I am taking this count equals to candidates, because we have to push the first four elements in the left heap. So in the first heap 1, we are pushing uh, four elements, first four elements in the heap. And how we are saying that it will fill only four elements. So because we have taken the count equals to candidates, and we are decreasing the count minus equals to 1, so it will be 0 after four attempts. And for the left and right hand side as well, we are taking the same thing. We are taking count equals to candidates. And here I am also checking that if you see the second example, we have to take the three candidates, and we are taking three candidates in the left hand side. So we are left with only one candidate in the right hand side, so we have to take only one element. So for this I have taken the condition while j is greater than or equals to I, and the count is greater than or equals to 0 is the same as the left hand side, and then pushing the elements in the heap 2. And after that we have to get k workers in k sessions. So for each iteration we are picking up an worker and adding it into our answer. So if the first heap is empty and we are left with only the right heap, so we have to pick the element from the right heap. If the second heap is empty, so we have to pick the element from the first heap. If both are non-empty, then we have to pick accordingly, like it is saying that we have to pick the minimum one. So if a heap 1 left hand side heap is smaller than the right right hand side heap, so we will be picking the left hand side, and it will be poking the element from the heap. And then in this example, if you see, like we have taken 17, 12, 10 and 2. So if we are taking 2, so the size of the left heap is only 3, so we have to maintain the size as 4. So we have to push an element, so we will be pushing the 7 element in the left heap. So we will be pushing the elements and the same as the right hand side. So yeah, this is kind of easy problem. Let me know in the comment section if you have any doubt. I will try to resolve that. Thank you. I will see you in the next video.